Okay, today we're going to look at Module 5, Lesson 5, the area of polygons through composition and decomposition. First of all, what's a polygon? Who remembers what a polygon is?
Like a shape, straight side, that's closed and straight sides.
That you're missing one part. It's a figure that's closed, has only straight sides, but you're missing one piece of the definition. Three or more sides, okay? So we're going to be looking at triangles and rectangles, all different shapes, and finding their area through something called composition and decomposition. So if you're writing a composition, so if an ELA or your DBQ in social studies, and you're told to compose an essay, what are you doing?
You're like making an essay?
You're making it. You're putting it together. You're putting all your words together to combine to equal one big composition. What does decomposition mean? If you're composing it and composition is putting it together, decomposition means taking it apart. Right. We're going to take it apart and look at the different pieces. Okay? So here the word compose is a verb. That means the act of joining or putting together. Decompose means the opposite, to take apart. So in this lesson, the words composition and decomposition are used to describe how irregular figures can be separated into triangles and other polygons. The area of these parts can then be added together to calculate the area of the whole figure. Is there a word in there that somebody's not familiar with, wants me to explain? Let me shut the door, please. What does that mean? Irregular figures. I'll do it. What do you think that means? Well, I know where you're going with it, but not exactly, because they're all polygons, so they could be classified as polygons. So I'll give you a hint. This is an irregular shape. That's an irregular shape. That's an irregular shape. Nice. It's a shape that does not have all equal sides. So these are all considered irregular. So a square would be regular. An equilateral triangle would be regular. Oh, that's not a regular hexagon. That was supposed to be a regular hexagon. Okay? So when all of the angles and all of the sides have the same measurements. So all the angles have the same measurement as each other angles, and all the sides have the same measurement as the other sides. It's considered a regular shape. So irregular shapes, we don't have formulas for their areas. All triangles are half base times height. All parallelograms are base times width. But what about this one? I see a triangle and a quadrilateral. This one, well, it's not just a parallelogram. Well, it's not a parallelogram at all. It's not a triangle, so what would we do? So let's say we're going to decompose them, find the areas, and add them back together. Before we jump into the areas, we have to figure out the measurements of some of the sides. So we're still on page 20 in your module, lesson 5. Now, they're giving us this figure. It's like an upside down L or a flag. Problem is, we're going to use this flag twice for 2 examples, but they only drew it once in your module. So be careful. We might have to write on it twice, but it's okay. It'll work out. So first, let's label this woodlot. So AB is 10 units. I'm getting this over here in the directions. FE is 8 units. AF is 6 units. And DE is 7 units. But what we don't know is DC. And what we don't know is DC. So we have to figure out the measurements of those two sides. I'm going to start with AB. Now this is where I love having a smartboard. So AB is up here. Parallel to that, I have FE, which is 8, and I have DC that I don't know. If I bring up my 8, and I bring up my missing side, it's equal to AB. So what is the measurement of this DC? If my whole thing is 10, and I know part of it is 8, what's my other part to total 10? Everybody? 2. So I know that DC equals 2 units. Now remember, these are not drawn to scale. So you can't look at the picture and go, oh, well that looks like it's like half of that size, so it's probably half, or, oh, I'm going to measure it on my fingernail. Okay, so 1, 2, 3, 4, okay, 1, 2, no. You have to use this mathematically. You can't eyeball it and try to figure out because they're not drawn to scale, and you can't use rulers either. All right, so now let's figure out DC. So I'll put my 8 back. I'll get that out of the way. Okay, whoops. All right, so now here I have, this is 6, so I could bring that over. Here I have 7, and I could bring that over. So now I know my two parts. I need the total. Before I have the total and a missing part. Here I have both parts and I'm missing the total. So what's the total here? 13. Is anybody not sure where the 2 or the 13 came from? Or why we subtracted the first time but we added the second time? Okay, now if you look on your note page, if you look on your note page, they're giving you a new set of measurements for the same figure. So if you want to either write above and below these other numbers that you just labeled, or if you want to just put a thin line through them so you don't confuse yourself, or if you want to quickly redraw the shape next to it, you can quickly redraw the shape to the right. That might be your best bet. All right, so DC is 10, FE is 30, AF is 28, BC is 54. So now what we have to do is find AB, and we have to find ED. So let's take a look. So if this is 28, and I slide that over, this is what I'm trying to find, and I slide that over. I know the top half, I know the total, so now I have to find out what that bottom half is. So what operation will I use?
26.
Okay. So DE is 26 units. We got that because we did 54 minus 28. Very good. So we're done with that. Ah. That's 28. So now our top piece, if this is 30, and that's 10, those are parallel, they're equal, so the total is 40 units. This is going to help us when we have to deconstruct irregular polygons to find the area. So are there any questions on what we just did? All right, the good news is we're really not doing anything new today. We're just applying everything that we've already learned. So now you're going to use the note sheet that you took from the outbox, which is page 21 from your module. But if you look at page 21 in your module, they really didn't give you any room to work. So being the fantabulous OCD, super organized teacher that I am, so that we have nowhere's logo work, I made this worksheet for you. The only difference is your worksheet says rectangle ABC, and my board says 1, 2, 3. It's the same thing. Don't let that confuse you. I'm not that super organized. All right. So, the intermediate school is producing a play that needs a special stage build. A diagram is shown below, not to scale, which means don't eyeball it, don't measure it, don't use ratios. So on the first diagram, which we have here on the top of your note page, divide the stage into 3 rectangles using 2 horizontal lines. So we'll draw a horizontal line here and a horizontal line there. So now we just decomposed it into 3 shapes. So let's label them shape A, shape B, and shape C. Okay? So far so good? The directions told us to deconstruct it that way. Yeah, that's a good point. We should separate it. But actually, since I'm creating 3 new shapes, it's okay, but that's a good point. So now here, let's look at shape A. I see here that this is 2 meters, but do I have the measurement for the height?
Yes.
Yeah.
What is it?
4.
4. It comes from over here. It was right here, so we were able to bring it over. So here is my new rectangle. So let's find the area. Area equals base times height. Area equals 2 times 4. Area equals 8 meters squared. We okay with that? All right.
So didn't we just
So, and that is the same as C. So if we just want to rewrite it now, so now let's take a look at shape B. This big rectangle at the bottom. I see that my base is 7 meters, but I have to figure out my height. I see a 9 over on that side. But is that 9 the height for that red rectangle? No, 9 is for the whole thing. So if we said before that that's 4, if I bring it over, the top part is 4, and the total is 5, how much is the bottom part? Oh, I just said the answer out loud. Did I say it?
Yeah.
All right.
5?
It's fun. When you do it over and over, I can think of something else while I'm doing this, all right? So yes, it's 5. I just want to see if you were paying attention, that's all. Sure. So do we see why this is 5? And that we said was 5. So area equals base times height. Area equals 5 times 7, 35 meters squared. But if we want to find the total area, we have to add them all together. So 8 plus 35 plus 8. Yeah, if you'd rather do that, 35 plus 16. Addition is commutative, so even though PEMDAS tells us to go left to right, we can apply the commutative property. 51 meters squared is our answer. Questions on where any of those numbers came from?
I'm a little confused as how it's why you chose B5 and that A and C.
Why I did A, B, and C?
Like why is A and C 4 and B5 for not when you're splitting that?
Because this 9 is now split here. And I could see from over here that this part, that part is 4. Because I know that's 4, so I brought it over. So 4 is part of the 9. So this other part of the 9 is 5. Because 5 plus 4 will total 9. Now, let's take a look at the same diagram, same measurements. It's still an irregular shape, but this time the directions are telling us to use vertical lines. So here is shape A, B, and C. They're all rectangles. So A, what is my height on A? And what is my width or my base? 2. So that one worked out nicely. So area equals 9 times 2. Area equals 18 meters squared. I know that C is the same thing. So now I have to look at shape B in the middle. So when I look at shape B, I don't know the base or the height. But I do know that if this is 4, and I bring it over to my 9, that's the top half. So what is the bottom half? What is that part of the 9? 5. So that is now the height of B. Now, if this whole base is 7, and this part is 2, and that part is 2, and I bring those down, 2 plus 2 is 4. How much is left to make my 7? 3. So now I see here, okay, so rectangle B is 5 times 3. So to find the total area, I add my 3 areas together. Same area. So it didn't matter which way we deconstructed that irregular polygon, wow vocabulary, we still got the same area. Okay? Now for part C, can I go to the next slide? Are we ready? You guys have any notes? For part C, the directions are similar but different. Now they want one horizontal and one vertical. So let's do this one horizontal and do that one vertical. So shape A, shape B, and shape C. So A, I see that my base is 2. What is my height? 4. So 2 times 4. No other shape has those measurements, so I can't carry it over to another one. A and C are different this time. Okay, so that was shape A. So shape B, ooh. So if the top half of the height is 4, what is this part going to be? 5. And now what is the base?
5.
If this is 2, and I bring that down, and the total is 7, what's this part?
5. It's all 5. That means it's a square.
Arian? So area equals base times height. Area equals 5 times 5. Area equals 25 meters squared.
First C, couldn't you use the data from B?
Yeah, so now if we look at C, I know that that's 2. But I know from this side that the whole height is 9. So I could just bring that over. So I could see here and bring that over. Okay? A square is a rectangle. A square, good thinking though, going back and looking at the directions. Not all rectangles are squares, but all squares are rectangles. Exactly. So now let's add them all together. So we have 8 plus 25 plus 18, 51 meters squared. Squared, it's area. It's always squared. Now we just did 3 examples of deconstruction. Let's take a look at construction. So here's this shape. Let me make it a little bit bigger so it matches. If I brought this down and then cut it off, it would look like this. So this shape here is the same as the one on top, except instead of breaking it into 3 smaller shapes, let's combine them all into one big square. How do you think we would find the area of this, our irregular polygon, by capping this off and creating another shape there? Let's take a look at it. So what are the dimensions of this new big rectangle? 9 times 7. Does everybody see where that came from?
Yeah.
So on the bottom of page 21 in your notes, label that big shape 9 and 7. Label the big shape 9 and 7. And I just got that from here. 9 and 7. Because these are the same shapes, just capped off. So the area of the big rectangle, so we'll call it the big one, area is base times height, area is 9 times 7, area is 63 meters squared. But I don't want this whole rectangle, do I? I have to remove that part. So I have to find the area of this smaller rectangle and pull it out. So what are the measurements of this smaller rectangle? This smaller rectangle here. What is the height? What What is the base? 3. So here's the smaller one. I should have done this in different colors. Area is base times height. Area equals 3 times 4. Area equals 12 meters squared. So when I found 63, 63 was this whole area. But I don't want the whole 63, do I? No. I had to cut that part out. That part is 12. So if I want to cut this 12 out, what operation am I going to use now? No. I just took it away. I took it away. I'm going to subtract. So now 63 minus 12, 51 meters squared. So I just filled it in, found the whole area, found the area of the area that I gapped in there, and then subtracted it, took it out. So that means my irregular shape still has 51 meters squared as the area. So method A, B, C, and now D all gave us the same area. So whether you deconstruct it into smaller polygons or construct it into a larger one and pull a piece out, you'll get the same area. Tomorrow's lesson, we're really going to be focusing on part D some more. So we're going to be getting a lot more practice on this. Tomorrow's lesson is the exact same, except we're going to apply it to real-world situations like wallpapering or painting your bedroom, which I know you do all the time. It's very real-world for all of you. So that we'll practice it again tomorrow some more.